welcome to our episode of Carrotgal Sister Chats. And today we actually have a brother on with us, so this will be fun. Not our actual brother. This is a special guest that we have on named Scott. And I'm actually going to share your website at the beginning so people know that. And then we'll get into it. I'll show you a little intro. So the website for Scott is utahbioagriculture.com, and he also has a Facebook page, and you can Google that same information, Utah Bioagriculture, on Facebook to find him there. Scott is the owner and founder of Utah Bioagriculture, and he mainly focuses on the regenerating of soils through biological applications. He has been on a really interesting journey to be able to work with the soil and our food web. I'm really excited to learn about this, and he does this through worm composting. So I hope that he'll share some of that with us too. He's won some awards and had some articles in the newspaper. You can check out some of those things on his Facebook page. And yeah, we're so glad to have you with us, Scott.
Glad to be here. Thank you.
Yeah. This is a really exciting topic for me. In my garden, I do no-till gardening. I tried worm composting one time and I was pretty squeamish, so I don't know, maybe I'll try it again and see if I can handle the squirminess of it. But I do love seeing worms in my garden, and I love seeing when there's I know when you till, you really break down that soil and the biology in there and all of the things in there. So this is really awesome. And I also know, like, the health of our soil is really, really important to the health of our plants and therefore the health of our humans. So, so we're really glad to be able to have this discussion with you. Jackie, did you want to jump in? And
yeah, before we let Scott share with us his story, I just want to let our listeners know, if you're listening to the podcast, we're going to have some really exciting things visually today on our video. So hop over to the YouTube channel. You may want to watch what we have for you today. You're welcome to listen, but when you have the chance, go and watch the YouTube video. You will not want to miss out on that. So Scott, we'd love to hear about your story, your background story, right? Like, share with us about your journey, where you're at, give us a little bit of background on what you do, the work in the world. We'll have some more questions for you after that, but let's start with that and we'll go from there.
Cool. So I got into the worm composting world back in 2015 when I was given a worm bin as a Christmas present, and it was my favorite Christmas present. So I'm a little bit of a unique favorite present there.
Love it. Any ideas?
yeah. And so it was kind of rough at first because I didn't really I don't know, I didn't really use a lot of resources. I had to figure things out. And so it took me a while just to get my worms happy and where they weren't dying. I made some mistakes where I accidentally started hot composting my worm bin and just learned a lot of things the hard way. But eventually I figured out how to keep my worms happy and healthy. And it was like one of the most rewarding things for me to be able to look in my bin and see a fat, happy worm. So it was a pretty cool experience there. And once you start composting worms, you'll get attached to them. I think in one of the news articles it says that he said, I don't remember exactly how he phrased it, but he said that I couldn't stand the idea of my worms being skewered or something on a fish hook. But yeah, they start to grow on you for sure. So I did that for it was probably about 6 months, and I left on a mission, a 2-year mission for the Church of Jesus Christ of Latter-day Saints. And so I had to put it on hold, but when it came back, I got more worms. I got a couple more bins. I started experimenting with different foods. I started going to Starbucks like every 2-3 days and picking up their coffee grounds, because that's a really good food for your worms. And I just got bigger and bigger, and eventually around summer of 2020, I believe it was, I had 30 bins. So each bin was about 18 gallons. So I had 30 main production bins, and I had some other bins that were kind of for fun, but had a whole lot of worm bins. And I was taking food waste from, I wasn't doing Starbucks at the time because they kind of shut down, like picking up coffee grounds there at the same rate that I was. But I was working with, it was acai at the time. It's now Crush, but acai stacked the waffle iron and the creperie. So every few days I'd go and pick up, I had a 5-gallon bucket there. They would toss their food scraps in it. And every few days I'd go and pick up that bucket, replace it, bring it back home, or not home, but to the building that I had my worms at, and feed it to the worms. And it's really crazy how fast they'll eat it, because I've seen banana peels disappear overnight. I actually have some videos I could probably show you of the worms. Just the video specifically I have in mind is eggshells. They would, oh, and I also picked up food from neaters for a little bit, but if you grind up eggshells, they'll eat it. It's so dang quick. It's ridiculous how fast they are. So I was doing that for a while. At that same time, I was taking a entrepreneurship class at USU, and I did entered like a business pitch competition, and one of the prizes was to have a video made for your company, and which I was selected for that prize. And I have Matthew Havertz made a video for me that's on my Facebook, not my website though, that covers what I was doing pretty in depth. So I was doing that for a while. Had a couple news journalists come by and do a couple interviews. But it was the summer of 2020 that I stumbled across the Soil Food Web School with Dr. Elaine Ingham, and she really focuses on soil microbiology. So back when I was doing worm composting, I understood that there was really good biology in the soil, and worm castings gave you really good biology, but that was really a vague term for me. I didn't really know exactly what it meant. Yeah. And so I stumbled across these classes. I watched a lecture of hers. I was on YouTube, and it all like made a ton of sense. I understood a lot more about the biology, the different roles of the organisms. And so I've been taking classes there and working on growing my worm castings to be biologically complete. And so having correct proportions and correct numbers of different organisms. So that's kind of where I am today.
Wow, that's so cool. Okay, couple of clarifying things, because sometimes people, well, I'm assuming we have people on here that know a lot about this topic, but I'm assuming a lot of people don't actually understand something as simple as a worm casting. So could you just break that down for us? Really, no pun intended. Can you break that down for us? What is a worm casting?
Yep, thank you. A worm casting is excrement from a worm. So to put it in appropriate terms. So a worm will eat food, and through natural processes, the food will be excreted 2 to 4 hours later. I don't know exactly, but it'll come out as a worm casting. Cool. And a few things that's really cool about that, because I learned this relatively recently. Worms are amazing. Like, they're awesome critters. Charles Darwin said something to the effect of, it may be doubted whether there is any other creature which has played such an important part in the history of the world as this lowly organized creature. He's talking about the little earthworm. Oh. And what I think is just amazing about them is they are kind of, Jacque, I know you mentioned you had the worms, but you're kind of squeamish about them. They're actually really clean, which you wouldn't really think about. But the worm is like the perfect composter. Anything that it eats, the worm's biology is so kept in good balance that it will kill any organisms, any disease-causing organisms, that it eats. So like Salmonella, E. coli totally sanitizes anything it eats. And what blew my mind is that even what it touches, it has mucus. They have mucus on their skin, and they're just like so full of good biology that the biology in the worm will outcompete, inhibit, or consume any sort of bad bacteria, pathogens, plant disease causing. So worms, anything that worms touch or eat is just totally cleaned and made ready for plants.
Cool.
Wow, that is amazing. That's amazing.
So the worm castings, people use them as fertilizer, is that right?
Mm.
Yeah, I've heard worm castings is talked about as like black gold because from the excrement from the worms, it turns into this really dark, rich black. It looks like dirt, but it's like
Yeah.
dark black. Um, so it's not dirt, but anyway, you can use it like that. So that's why people call it black gold, because it's this really powerful fertilizer for your plants and things. So anyway, just wanted to break that down really quickly. Again, no pun intended. Maybe that was intended. Anyway, that is, what a cool story. And Scott, you and I live in the same area in Cache Valley, Utah, northern Utah. So all those local businesses that you were talking about, I'm like, oh yeah, I know exactly what you're talking about. But if you live in a different area, then that's okay. He's just talking about local restaurants that have food waste. So that's really neat. So fill us in on, I'd love to hear more about the story, because you mentioned that you kind of took a pip, like cool story about how much you love worms and your journey with worms, right? Like we could probably talk for hours just simply about worms, because I had no idea that they were that cool, but thank you. Now I'm going to geek out about worms too. But I'd love to hear a little bit more about this pivot in your story, right? From middle of 2020 and where you're at now with all this other knowledge and information that you're learning about, because really from what you're telling me in the story, I'm sure where we're going is you were really interested in the worms, which is from the little that I understand about soil science, the worms are actually like the top of the quote unquote food chain in the soil, right? Yeah. But there's like 1,000 layers and a million other things that actually build up to the worm. So like the worms are like the lion of the food chain. I mean, like the top predator, they're not predators, you know what I mean? Like they're like the top of the food chain, but there's a whole bunch of other things down below. And it sounds like you've been studying extensively all the other stuff that builds up to the worm. So I'm really excited to hear about what you've been learning since and how you're helping people as a result of that.
Yeah, so it kind of like I'll go more in depth on it. So I was away for the summer. I was having someone else run my worm operation, but I had a goal to learn something new about worm castings every day. So I was reading books and things, and I remembered like worm castings, their NPK, nitrogen, phosphorus, potassium ratio isn't super high. It's not what you would think of when you think of a fertilizer. It's usually like on like 100 sometimes, or maybe 111, but pretty low NPK. And I realized that the main benefit was the biology, and I had done a little bit of research on that, like Google Scholar, like papers on it and whatnot, but it was still kind of like a hazy, vague term. Like I said it, but I didn't really know what it meant. So I came across this lecture by Dr. Lane Ingham. She's the owner of the Soil Food Web School, and just the way she explained it was, and the science behind it is, it just, everything made perfect sense, and it's totally changed like my perspective on the soil. Do you want to look at the microscope now? I can kind of introduce some of the organisms. So
Scott has hooked up his microscope to his computer for us, so he's going to show us under the microscope. So he's going to share his screen with us, and we're going to take a look under the microscope.
I feel like I'm on a roller coaster ready for it to launch. Ready to go.
Is that coming through?
Yeah.
Okay, sweet. So it looks like my slide's starting to dry up a little bit. This is an air bubble that's getting into it. But some of the organisms here, and the two most important are bacteria and fungi. Well, I don't know about important. They're all really important. Mm-hmm. We'll come back to that nematode here in a second. So the two primary decomposers in there, like, I forget if it was Jacque or Laura talking about it, but they're at the bottom of the food chain. This right here is a strand of fungi.
Okay. The long thing across the screen?
Yep. Okay. This one as well.
Oh, wow.
And fungi and bacteria, and there's just a ton of bacteria. Most of these dots, like the ones kind of bustling around, I don't know if that's the right word, but sort of
moving.
Mm-hmm. Those are all bacteria, and those are like kind of that's where it all starts.
Okay.
In the soil, there's only two true decomposers, only two organisms that are actually decomposing and doing the work, and it's the bacteria and the fungi. Everything else is going to be a predator of some sort. And so one of these predators are nematodes, So this guy right here is a nematode. And you can tell, I don't know if this guy will show very easily.
Oh, wow.
He is a bacterial feeder. You can see that pump. It looks like a T shape. It's the shadow right there. But he has a little pump. Tells us that he's a bacteria feeder. So he eats bacteria, and there's other nematodes that eat fungi. In here are also other predators, like we saw testate amoeba a second ago. I might have lost him though. But there's a lot of different organisms that will eat. Oh, here's a testate amoeba right here. Right there in the center of the screen. And they don't move so much as the other organisms.
The little circle one.
Yep.
Oh yeah, that one.
Right there. So they're called testate amoeba because they have a shell. It's called a test. And so a testate amoeba. It would probably take me a second to find some amoeba and some flagellates. Flagellates are pretty small, they're hard to see, but there's some in here as well. But basically how it works is the bacteria and the fungi are the true decomposers, and they'll decompose sand, silt, and clay, organic matter, really anything in the soil to get nutrients. And they're extremely nutrient dense. Bacteria have a carbon to nitrogen ratio about 5:1. So they have a ton of nutrients that plants need, as well as the fungi. The problem is the plants can't get the nutrients from those organisms until they die. And so that's why we need these predators, that's another testate amoeba right there in the center. The amoeba, the flagellates, the nematodes, sometimes ciliates or other protozoa that will eat the bacteria, will eat the fungi, and will excrete the excess nutrients. So protozoa, or like nematodes, for example, their diet for carbon nitrogen, they need a ratio of 30:1. And so they need to eat 6 bacteria to get their 30 carbon, and they have 6 nitrogen in their diet, for example, but they don't need that much nitrogen. So they excrete it out as a plant available form, and the plant's ready to take that up right away. And what the plants do is they release, it's called exudates from their roots. And these exudates, it's photosynthate. Forget exactly what it is, but it's like sugars and I want to say carbohydrates and proteins, something or other, to attract all these organisms. They want to attract the bacteria, attract the fungi, because if the bacteria are there and the fungi are there, they're decomposing what's around the roots and getting nutrients that the plant wouldn't be able to get. And then when these predators come by, they eat the organisms like the bacteria, the fungi, and release the nutrients right next to the root of the plant.
Oh.
So that way you're able to get nutrients from the soil. And I'm not prepared with enough information to go in depth on this part, but Dr. Lynn Ingham talks about how there's no nutrient on the planet or there's no soil on Earth that lacks the nutrients necessary for plants to grow. It's just locked up in the silica structure of the sand, silt, clay particles.
That's fascinating because we always talk. I've heard about dead soil. But you're saying it's not actually dead. It has the nutrients in there, just no life to be able to get it out.
Yep.
Wow. That's
so dead. Like I on my website, I have a picture, and I can kind of simulate here, but that's some really good looking fungi right there, by the way. But yeah, if you look at like an agricultural soils that are getting tilled, you're going to see nothing. You're going to see nothing but bacteria and sand, silt, clay particles. Everything is dead. Especially if they're using chemicals. And so none of these processes are going on.
Yeah.
Yeah.
So what we're looking at right now, this came from your worm farms, your worm composters, is that right?
Yep.
Nice.
Yep. And this one I've been working on specifically just to grow fungi because it's been a hard organism for me to grow. But this is to experienced eye, this is a beautiful hyphae of fungi right here. So
are you talking about like the loopy thing?
Yep.
Okay, I'm assuming it's the loop, but I've never seen this before, so I don't know what you're referencing.
Yeah.
I've never encountered a microscope, but I'm always happy when I see fungus in my garden soil because I'm like, oh, it's alive. It has good stuff in it. So,
and a little bit more about it because these organisms do a heck of a lot more than just the nutrients. everything a plant could need, really. So the predators like the nematodes, the protozoa is an umbrella term, it's the flagellates, the amoeba, the naked amoeba and testate amoeba, and some others. But these organisms, they obviously like the plant because the plant's farming the bacteria, it's farming the food. The plant's attracting all these organisms, the food for the predators. And so they like the plant because it's providing them, there's a symbiotic relationship there. And if they will actively go out of their way to destroy plant pathogens because they eat bacteria and they like the plant. And so if they notice that there's bacteria that's harming the plant, they go out of their way to kill it. And so they go and eat these organisms. First of all, the plant's root should be pretty much totally covered in bacteria and fungi to where disease-causing bacteria and disease-causing fungi can't find the plant. But even if it were to, these predators will actively prioritize those organisms first. And so they'll kill those organisms. So the soil food web is providing for the nutrients, is providing for the health of the plant, obviously helps with water retention, as well as soil structure and even weeds. It'll help control which sort of plant grows. And if you have a soil that's more fungally dominated, weeds won't grow in it. They prefer, just because different plants prefer different soils, and weeds don't grow in fungally dominated soils.
Wow.
So the more alive your soil is, the healthier your plants will be, right?
More diverse, yeah. Because I mean, it can have a lot of bacteria, but if bacteria is the only organism, then it's probably going to be growing a lot of weeds. So yeah, I mean, you want it more diverse, and depending on what plant you want to grow, like trees need a really fungally dominated soil where there's, as far as biomass to biomass, there's a lot more biomass of fungi than there is bacteria. Mm-hmm. A lot of the row crops that we're growing, like tomatoes, corn, those sorts of things, they prefer a 1-to-1 and equal ratio. Weeds will thrive and dominate other plants in a high bacteria, low fungi soil, like a 0.3 fungi to 1 bacteria soil or less is where weeds will thrive and dominate.
Wow. Okay, so I have a question for you. How do you help people? Because this is great, and I love listening to you, but obviously you have such a wealth of knowledge. So like, how does what you understand actually get like in real life with people's yards and in different spaces? Like, how do you actually show up and help people? Is it like just individuals that you're helping, or are you helping farmers with large properties, or what does that look like in your everyday life?
So I've just begun. I'm mostly working with like a couple homesteaders right now, nothing too big. Like I said, I just sort of began some of these classes, and I've been working on, I'm a certified lab tech. And so I've had the training done to analyze soil, and we actually, there's a process to get a number of like the fungal biomass in grams compared to bacterial biomass in grams, and how many flagellates, how many amoeba per gram. I could probably show you a report that I did a couple of days ago, but as far as actual applications, I'm still working on that. But how that would work, and it doesn't really matter the size. It could be very small scale, it could be very large scale, but get a, sorry, I thought I saw a flagellate swim through the screen, but so you take a look at the soil, figure out where it's at and where you need it to be, and for what kind of crop you want to grow, because it depends. And then I would create the compost, and it's like a, maybe designer is the right word for, I don't know, but it's a very like, it's a process to make the compost, because you have to make you have to have diversity of organisms in certain ratios. Anyway, you make this compost and you extract the organisms from that compost into liquid. So kind of like what I did here to get this sample. I had about one gram of soil in here and 5 milliliters of water, mix it up. So this water right here is totally chock full of all these different organisms.
Wow.
That's the same thing you do, is you make this compost, you extract the organisms into the liquid, and then you apply the liquid at a really, really low dilution. You don't need to, you're just inoculating the organisms into the soil because they'll proliferate, they'll reproduce.
Wow.
So you apply these organisms into the soil, whatever it is, and more often than not, you're going to need to add some organic matter, some food for them, some leaves, wood chips, manure, things like that. And then they'll start to grow in the soil on their own. Eventually, when there are plants growing, the plants will become self-sustaining because the plants will produce organic matter. They'll produce the food for the organisms with their exudates from their roots, the photosynthate. And so you don't need to be constantly adding organic matter, but I think that answered your question, right?
Yeah. So it sounds like, from what I understand, so if anybody wants to figure out how to get their soil healthier, they can contact, and we'll share with them how to contact you, right? But they can contact you, and you can do an analysis of their soil. You figure out how to get their soil from point A, where it's at currently, to where they want it to be based on the plants that they're wanting to grow. And then do you create the specific compost for them, or do they do that? You do that?
They could. I mean, the microscope's pretty key because the microscope is actually how you can tell what's going on. I mean, you can't really look at a soil and know exactly. I mean, you can get kind of an idea if you've got a trained eye, but the microscope is really how you're certain that the compost is, or the organisms in the compost are where you need them to be.
Yeah, that's great. Okay, so you take care of that, and then you help to create the liquid that they need in order to inoculate their soil, and then they're in charge of feeding it and helping it to get to that point where it needs to stabilize so that they can grow the crops. That is super cool. Cool.
The one of the really nice things about it too is that and this is all Dr. Lainey Ingham, by the way. I didn't pioneer any of this. This was just from her classes that I took that I'm willing to, if people have questions, I can answer for them. But if you have a really good compost, which I wouldn't have a compost quite this good yet, but if you have a really good compost, you can use as little as 1 pound of that compost to treat an entire acre. Just because you're not using nutrients, like the soil already has the nutrients, you're just getting the organisms. And the organisms will reproduce. Like nutrients don't reproduce, a pound of if it was just the raw chemical nutrients, it's not going to do a whole lot, but it's the organisms. And so you just spread it out in an acre, and if conditions are right, and again, this is assuming pretty ideal conditions, but still, like, you get the idea. 1 pound, you get those organisms all out to that whole acre, and they'll just reproduce themselves and proliferate and set up their own ecosystem.
That is so cool. I am a very big sourdough geek and all things, what's the word? I just lost it. When we're fermenting things, and it's the same concept. Like, I see that same pattern, that same principle in fermenting. To make sauerkraut, you take a head of cabbage, you cut it up, you add salt, the natural yeast and bacteria in the air do its thing, and they inoculate the whole thing, right? It's like, I didn't have to do that. That's really, really, really neat. I've never been exposed to that same thing in terms of the soil. So that's really cool. You just highlighted that.
Yeah, and so many, nature is amazing, like so cool that there's so many living things in the soil that we don't really know. We don't see because we don't have microscopic eyes, right? But it's amazing what's living under the earth, and that you have figured out how to create the right creatures and inoculate the soil to be able to unlock the nutrients. I think that's amazing.
So cool. Well, beautiful. One other question I wanted to ask you is, how, do people have to be physically close to you in order for you to help them? And if not, how far away, is this done? Can they mail you samples? How does this work? How far away can people be for you to help them?
Yeah, so samples, it's best to be able to identify them or look at the sample as if it were still in its original condition. So, I mean, especially if you're sending a soil in a package that's sealed, it's losing oxygen. So different organisms start to grow, like the battle organisms. And so The main constraint is overnight shipping. So if it can be there in 24 hours, and there's some guidelines for that. I've really mostly just been working with people in my area, so I haven't had to come across that, but it is an option to ship it. You got to be a little bit particular in how you do it. You got to make sure you leave enough air in the bag. You can't put anything else in the bag because it might start to decompose, and so other things like that. But for now, I've mostly just worked with people in Logan in the area, but I mean, I could be open to reaching out for sure. Won't say no to that.
Cool. No, I just wondered because I'm like, I think people probably wherever they're at, if they need this kind of help and support, if they're not, I know that's difficult when you're running your own business and people are like, wait, you do what? Why are you X amount of hours away from me, you know? But if there's other options that they can still access you, then I think that's lovely, because I have no idea where all of our listeners are at. And I think some of them are not here in our local area. So I just wanted to ask you about that and what that looks like.
And I can, so I kind of do the two different things. I do the biological services, and I also do like worm composting. I have guides on my website that I'm working on. I have like 4 or 5 up there right now. Life happens, so I haven't been posting them as often as I can, but I'm also 100% willing to take phone calls if you have questions about worm composting. Like I don't mind talking about worms on the phone, so you can call me. And I can ship. I have urban worm bags that I can ship. I can get red wigglers, things like that to help you get started on the worm composting side of it as well. So
cool. And I saw all of those products they're listed out on your website on your shops tab. So check there. He's got lots of worm composting supplies. And like you said, do you want to explain just real quick the red wigglers? Most people are familiar with an earthworm, but why would we use red wigglers rather than other worms?
So I have to check my pronunciation on this because I mostly see it written or typed. But the normal earthworms that you see like outside, they are, I believe it's pronounced endogeic earthworms, and their lifestyle is a little bit different than composting worms. They usually have burrows, and their feeding and living style is a little bit different. But the composting worms, and there's 4 or 5 depending on how you want to count them. But red wigglers, Essenia fetida. Again, I'm not sure the pronunciation. So red wigglers, European night crawlers, African night crawlers, and sometimes blue worms, or sometimes Alabama jumping worms. Not so much the last 2, but anyway, these composting worms, they thrive in environments that you would want a composting bin to be like. So like leaf litter is kind of the go-to word of the conditions they like to live in. Because the worms outside, you put them in a compost bin. Like I just have these 18-gallon bins, and they're going to get stressed out. It's not where they're going to thrive. And so red wigglers are kind of the default go-to. They're the classic composting worm, and they just do better in a compost bin.
Yeah. Cool. The little experience that I had with it, a night crawler earthworm it likes colder conditions, and your compost is going to heat up just a little bit, right? So the red wigglers tend to do better in that warmer environment. Is that kind of a good way to think about it too?
Yeah, you don't really want your compost heating up too much, really much at all, really, with the worm bins. They'll start to die at around 90 degrees. And I mean, their ideal temperature is 77, but like, starting to get into the 80s, they're not going to be very comfortable with it. But
cool. If somebody wanted to start a worm bin on their own, do you want to take us through that process in just a couple minutes here and just share what they would need to do?
Yep. So I have a guide that I'm pretty proud of on my website. It's just how to start a worm bin. Goes through it pretty good. But the 2 bins that I've liked the most, I've liked the urban worm bag the most. I've tried a lot. The urban worm bag is going to be the best for a beginner. There's more room for error. But if you need to be a little bit more budget conscious, you can also just get like an 18-gallon bin. That's usually what I use. I mean, worms don't care too much what size the bin is, but that's just always what I've used. You have to be a little more conscious as far as the moisture content in the plastic bin, because it collects in the bottom. There's nowhere for it to go. But you want to get your bin, make sure you're aware of the strengths and weaknesses of the bin that you get, and cater your what you do to those strengths and weaknesses. But I always recommend cocoa core is an amazing worm bedding to get started with, especially because it comes with instructions on like how moist to get it, and that's going to be a really good moisture level for the worms. It's really hard to go wrong with on the bedding for cocoa core. Also, shredded cardboard is a really good one as well. You need bedding that's going to be, it's carbon rich, so you don't want it to like be nitrogen rich. You want it carbon rich, good airflow, and hold moisture really well. And honestly, if you just get a good bedding in there in the bin, you keep the moisture at a good level, not too much. You don't want it to go anaerobic. It shouldn't be smelling at all. There shouldn't be any pests or odors. But if you have a good bedding, it's really hard to mess it up from there. If you put in a food that's bad for the worms, they'll just avoid it. They'll just go back into the bedding, and you'll start to like figure out how the worms communicate, what they like and they don't like. Like if you have good quality bedding and you want to test out a food, you don't even need to Google it at a certain point. You don't need to check. You just put it in there and your worms will tell you, oh, I like this, or oh, I don't. If they like it, they'll go into it. If they don't, they'll avoid it. But as long as you have good bedding, if you make a mistake, as long as you have a section of good bedding that you don't really mess with, that you don't interfere with, you can make any sort of mistake in any different place of the bin and you'll be fine because the worms have a safe place to go to. So that'd be my main thing, is just pick which.
You put food scraps on the top layer, right?
It kind of depends on what you're feeding them. Usually the school of thought is to bury it though.
Oh, really?
It kind of depends. Like I did a handful of different trials on like food scraps and stuff, but if it's buried, things like banana peels, it's going to be harder, like fruit flies to get to, pests, things like that. So cool. Yeah, it kind of depends, but usually burying in little pockets is what people do. It's like a little small handful and bury it and then move it around. But yeah.
Okay, that's awesome. And then how long after they start a worm bin would they be able to harvest castings?
So it totally depends. Depends on how big your bin is, how many worms that you have, what you've been feeding them. So I can't give you an exact answer on that. It just totally depends. I had African night crawlers. My 30 bins were all African night crawlers, and they eat significantly faster than red wigglers. They're a little bit more high maintenance. They require certain temperatures. Anyway, I do recommend red wigglers for beginners. But anyway, these African night crawlers, they could eat. I'm trying to remember the exact. I had the pounds written down at one point, but I'm trying to think of real numbers to work with. So an 18-gallon bin, I probably have like a third filled with compost. Part of the time that I had them, I was using compost. I was just feeding them compost, and they would eat like 6 gallons in like a week. I want to say maybe probably a little bit less. And then you can have worm bins that take you like months. Mm-hmm. And there's nothing wrong with one way or the other. It kind of depends on what you're feeding them. Like this worm bin I have right now is more fungally dominated, so foods that don't break down so quick. So it totally depends.
Okay. Yeah. Just like all living systems, right? It's back to all the things like that I mentioned, like sourdough bread. You can't really there's general guidelines, but you have to watch it because it's this living thing. So I like that you mentioned that, right? Like watching your worms, and you'll notice how they communicate. Like, we don't like that, or we really like this, and we're going to eat a lot more of that. So I like that. That's awesome.
I might have a video. Let me see if it's quick for me to pull up of my worms eating eggshells. Oh, and okay, looks like I do have the video still. Okay, let me screen share this. So I recorded this. This is eggshells. So I did a ton of powdered eggshells, and so these are worms. I know it's kind of gross, kind of squeamish here, but believe it here in a second in the video, you can just see all of them coming out. They're coming out to eat these eggshells, and these eggshells would disappear in like 30 minutes. You can see them right here. I'm not sure why it's doing that. The video's being a little bit weird, but
So
you get the idea. They can eat ridiculously quick. I've seen banana peels disappear overnight, things like that. So.
And how cool that you can take food scraps, things that were going to go into the garbage, feed them to your worms, and then that feeds plants, which feeds people. It's awesome. Like such a cool thing to use waste effectively. So
good. Cool. Well, Scott, thank you so much for, my goodness, sharing your story with us. I have learned so much. I feel so much smarter as a result of talking to you today. We will definitely, like we've said a couple of times, we'll definitely post how to connect with Scott on his website, his Facebook information, so that in case you have more questions, he offered to talk to you on the phone about worms. So if you have questions, contact him. We've just been delighted to have you on here today. So thank you so much for everything that you've shared with us. I feel a lot more passionate about worms than I did an hour ago, which is
always the goal.
I know. Scott said before we started recording, he's like, I am on a, you didn't say this exactly, but I'm on a mission to educate people about worms. So you have accomplished your mission, at least for tonight. So thank you. Seriously, thank you. That's really beautiful.
Thank you guys so much for having me.
yeah. All right. Thank you very much. And we'll talk to you guys on the next episode.